This is Mr. Beck Does Your Homework, AP Physics, Homework 4.3, question number 11. A 17.1 kilogram person climbs up the uniform 102 Newton ladder. The upper and lower ends of the ladder rest on frictionless surfaces. The bottom of the ladder is fastened to the wall by a horizontal rope. The angle between the horizontal and the ladder is 52 degrees. Find the tension in the rope when the person is 1/3 of the way up the ladder. The acceleration of gravity is 9.8, answer in units of newtons. This picture shows me most of the forces. I've got a tension this way, I've got a gravity this way, I've got a gravity this way. I've also got something up here. What I've got here is a normal force in this direction. Now, I don't know what the normal force is, and frankly, I don't care what the normal force is. What I'm interested in is the tension down here. So I'm going to treat this like a torque problem, since it's on the torque homework, and I'm going to pick the top of the ladder, that normal force, as my pivot point, because then I don't have to care about what that normal force is. So now, think about that as the pivot point. What's going to happen with each one of these forces? Which is clockwise, which is counterclockwise? Oh, sorry, I have one more force here, and it's a normal force up this way. Okay? So each one of these forces is going to do something. So if I pick this as my pivot point up here, then this one down, the gravity of the ladder is pulling it counterclockwise. The gravity of the person is pulling it counterclockwise. The tension is pulling it counterclockwise. And this normal force from this end is pushing it clockwise. So again, I'm going to have a torque problem where I've got my counterclockwise equals my clockwise. So counterclockwise, I have the ladder, so that's going to be an RF sine theta. I have the person, so that's going to be an RF sine theta. I've got the tension, that's going to be an RF sine theta. And all of that is going to equal this normal from the ground, and that's going to be an RF sine theta. So let's do one at a time. The ladder, the radius of the ladder is going to be the distance from here to the pivot, which is half of the length of the ladder. So that R is going to be, for me, 7.5 over 2. The force there is 102 newtons. And the theta there is going to be this angle between the radius and the force. Well, I could pick this big angle, but I'm going to pick this smaller angle because that's going to be easier to do. Now, if this is 52, that means this is 52. This is going to be 90 minus 52. So that's going to be the sine of 90 minus 52. It's going to be this angle. Same thing with the person. So I've got a plus R for the person. Well, that person is 2.5 meters from this side. So 7.5 minus 2.5 will give me 5. The force is going to be 17.1 kilograms times 9.8. And the theta there is going to be the same as the sine of 90 minus 52. To that one, I'm going to add this third one. So this is just a continuation. The third one is going to be the tension in the rope, also pulling along. So that's going to be, at the length of the ladder, is 7.5 meters. The force is going to be T. And the theta I have there is 52 degrees. Now, all of that is going to equal this normal force at the full length. So the R is going to again be 7.5. The force is going to be my normal force. And the theta for this one, well, let's see, what's this angle going to be? That's going to be the same as this one, this 90 minus 52. Okay? But wait, I've got T that I don't know, and I've got force normal that I don't know. But I do know my normal force here, because now I can use a little up equals down to figure out my normal force. So for the normal force, I got up equals down. Well, up is just my normal force, and down is going to be my 102 and my 17.1. This one's to the left, this one's to the right, I don't care. So my normal force is going to be 102 for the ladder plus 17.1 times 9.8. So those two forces down must be balanced by my normal force up. So now I know my normal force as well. So this is a number, that continues, add this, but I've got a t sine 52. This I all know because I know the normal force from this one. And since my only unknown here is t, I can solve for t by figuring out all this. This minus that one, divide by sine 52, divide by 7.5 will give me my t. So that'll give me t equals. Big complicated ladder problem, but there you go.